All right, we are moving into some more trig identities. So hopefully you know your trig identities by now. We are moving into verifying. With verifying, you have no choice but to show all of your work because, well, you have to. So we're going to get started. We have sine theta over cosine theta minus cosine theta over 1 minus sine of theta is equal to the negative secant of theta. So the first thing that we're going to do here is we need a common denominator on the left side. How do I find a common denominator? Well, I'm just going to multiply what is on the right side in the denominator. So that's the 1 minus the sine of theta by each. And on the right side, I'm going to multiply the cosine of theta, because that's what we need. And let's see what happens here. On the top, well, I'm going to draw one straight vinculum. So on the bottom, I do just have the cosine, sorry, I'm struggling with my little pen today, of theta, times 1 minus the sine of theta. And remember, this is still equal to the negative secant of theta. But on the top here, when I distribute this through, I have sine of theta minus sine squared of theta. And then this is minus the cosine squared of theta, because cosine of theta times cosine of theta. Now, as you can see, I have a trig identity here. So hopefully you know your trig identities. If I was to factor out this negative, this would be sine squared theta plus cosine squared theta. And what is that equivalent to? Good, you guys know your trig identities, and that is 1. So I have the sine of theta minus 1 all over the cosine of theta times 1 minus the sine of theta. And again, all of that is equal to negative secant of theta. So we have to decide what's happening here. But again, if I factor out another negative, I now have 1 minus the sine of theta and 1 minus the sine of theta. So voila, these can cancel out. And on the top I have negative 1, and on the bottom I have cosine of theta, and all of that is equal to negative secant of theta. Well, hey, I know my trig identities, and I know that negative 1 over cosine theta is equivalent to negative secant of theta. And I'm just going to write that these are both equal. You guys are complete rock stars at factoring. So in example 6, they're telling us to factor each expression. Well, I know that if I have the difference of two squares, I will always have a plus and a minus. So the perfect square of 1 is 1. And the perfect square of cosine squared x is cosine of x, and cosine, again, this pen is weird. Sorry, I don't have my typical Apple pen, what I use. Cosine of x. Moving on. Oh, this looks like a mess. What in the world are we supposed to do here? I like to look at this mess. Let's just call it a. So I have 2a squared minus 7a plus 6. Well, from my old school factoring, I know that this is going to factor to be 2a minus 3 and a minus, whoops, that should be a minus, come on, minus 2. Because if I multiply these, I get 2a squared. The outers are negative 4, the inners are negative 3, which add up to be negative 7, and the last multiply to be positive 6. But I know that that a squared is not an a squared, it's a cosecant squared x. So I'm just going to rewrite this with a cosecant x minus 3 and a cosecant x minus 2. These next factorings always catch me off guard because all of a sudden they're going, hey, we have a secant and a tan. Have fun with that. So What do I know about secant? Well, I know that secant is equal to 1 plus tan squared. So instead of writing secant right here, I'm going to write 1 plus tan squared x because I know my identities, plus 3 tan x plus 1. And when I add like terms, I do have a tan squared x plus 3 tan x plus 2. And I would ask you, just like I would in Algebra 1, what are the factors of 2 that add up to be 3? Perfect. They're going to be 2 and 1. They multiply to be 2. They add up to be 3. So I know that this can continue to be tan of x plus 2 times tan of x plus 1. Nice, and that's the answer. All right, let's do one more. They're asking us to simplify the cosecant of t minus cosine t times cotangent t. Well, this one doesn't look like much fun because nothing's the same. So the first thing I always encourage my students to do is take everything and put it into sine and cosine. So I know that this is 1 over sine of t. And I know that this is cosine of t, and cotangent I'm going to put as cosine of t over sine of t. Well, we kind of have a like denominator now, don't we? We do. So on the top, it looks like I have 1 minus the cosine squared of t, because hey, cosine times cosine is cosine squared, all over the sine of t. And look right here, this is a trig identity. Hopefully you recognize that. That's equal to the sine squared of t over the sine of t. And this will equal sine of t. So it's kind of a little puzzle. I will encourage you to always take your identities and put them into sine and cosine. So the cotangents, the cosecants, the secants, and the tangents, and then work from there, finding a common denominator and doing other things like that. Great job today.